This will be a review of Exit Slip 16, where we talk about logarithms. So this was our first day studying logs, so we learned an important rewrite between logarithmic and exponential forms. So it looks like we're going to need that in this exit slip. Let's go ahead and just start by writing that on the other page, just as a reminder. So if I have log base b of x is equal to y, let's just write it out here, then the transition to exponential form would look like dropping the base and crisscrossing. So in case that helps, basically we're dropping and crisscrossing, and this would be the equivalent exponential form here on the bottom. So this top form is what we call the logarithmic form of the equation, and then the bottom form is what we call the exponential form of that equation. So let's see if we can try that out with the first two problems on the exit slip. The first one says rewrite log of 100 equals x. So you might feel like we're missing something. The base isn't actually stated. But if we stop and remember, the only base that doesn't have to be written, that's understood, is a base of 10. So log of 100 really implies log base 10 of 100. So I'll write in that base just to make the transition a little easier. So then when we drop the base and crisscross, we will get 10 to the power of x is equal to 100. And we could go ahead and solve that, but the goal for the exit slip here was just to rewrite it. So I'm going to stop right there. So 10 to the power of x equals 100 would be the rewrite of that original logarithmic equation. For number 2, it looks like we're doing the same thing but in reverse. So for number 2, we're given an exponential equation and asked to convert it to logarithmic. Same idea though, we're going to drop the base and crisscross. So now we're going to have a log base 4 of 64 is equal to x, and that would be the equivalent logarithmic equation for the given exponential. This third one is going to have a similar feel to the first two, but we're going to actually solve it all out. So for number 3, we're asked to solve by converting to exponential form. So the same thing we've been doing here. We will drop the base of 5 and then crisscross the x and the 1 over 25, and then we'll actually finish solving this one. So if I have 5 to the power of x is equal to 1 over 25, a good solving technique with exponentials is to see if you can make the bases match. And in this case, we can make them match if we're careful. So this 1 over 25 on the right-hand side could be thought of as 1 over 5 squared, right? 25 is just 5 squared. And then I can bring the 5 squared up to the numerator as long as I make the exponent negative. So at this point, the base on the left and the base on the right are the same. Therefore, the exponents must be equal. So at this point, I can say it must be true that x, which is the exponent on the left, must equal -2, which is the exponent on the right. So this would be the solution for that original equation. So hopefully we're doing pretty good with the log to exponential and vice versa. And that's it for this one.